Hello, good morning, everyone. Let's discuss the question MYE compilation, right? MYE preparation compilation. You can open in my Google Classroom. For students who watch this video later, please open your Google Classroom. You will see and find the questions MYE preparation compilation. There are some questions here, number 1 until number 13. All questions are structured questions. Now, students, wait, for number of 10, it is not included, okay? For number 10, is this not included because this is not in the syllabus of IGCSE 2024-2025. No, not included, not in the syllabus number 10, not in the syllabus. Okay? Do not include this, okay? This is manometer. Okay, let's start from number 1. Let's start from number 1. Are you ready? Thumbs up if you are ready, students. Prepare your iPad, prepare your books, right? I don't want you rely only on my annotations, right? Because by writing, you will save more memory in your brain, right? Okay, you must make your brain sharp. Okay, the diagram shows children about to run a race. They have to run 25 meters, pick a small plastic ring, and run back to the baseline. Each child finishes when they cross the baseline holding the plastic ring. Suggest what equipment the teacher used to measure the length of 25 meter. Of course, meter, ruler. Yeah, meter, ruler. Distance, distance, the total distance of race for the race. They have to run 25 meters to pick up the small plastic and run back the baseline. Each child finishes when they cross the baseline holding. Now, from the base distance, distance is the total track, right? So the total track is, let's say baseline is BL and then plastic ring is P. Now, total track is from baseline to P to plastic ring plus from plastic ring to baseline. So it is 25 plus 25. You get 50 meters. Correct, students. You get 50 meters. Understand? Okay. Number 2. Number 2. A train of mass. What is this? Mass M. So the M is 5.6 times 10 power 5 kilogram at rest. Please underline this, at rest. At rest means initial velocity U equals to 0 meter per second. At the time 0 seconds, a resultant force acts on the train and it starts to accelerate forwards. Accelerate forwards. It means the velocity changes. The graph is the distance time graph, ST graph, for the train for the first 120 seconds. So the maximum time is 120 seconds. The motion recorded is from 0 second until 120 seconds. So here, students, the distance is S, the time is T, right? We want to use this data to analyze what is asked in the question. Okay, let's see the question number 1. Use the distance time graph to determine the average speed during the time 120 seconds. During the time 120 seconds. When the time 120 seconds, it is here. What number is this? Can you check your script, students? This is 40, right? This is 40. This is uh sorry, 40. This is 4,000, and then this is 5,000 meters, right? And then we have the 10 scales. So its square is 100, right? Its square is 100. Correct, students? So the distance at 120 seconds, how much, students? Huh? Answer me.
4,800.
4,800, yeah? Do not make me uh become Dora Explorer, yeah? I give questions and I answer by myself. Please respond, yeah? You are not deaf, you are not mute, okay? 4,800 meters. So we know that the average speed is the distance, the total distance over time. The total distance is 4,800 meters. Where do we get that? We get that from the graph, right? From the ST graph here, 4,800. That's why your ability to read the graph is really important. It's really, really crucial. And then the total time here is 120 seconds, right? Oh, where is my calculator? Okay. We want to be quick. Yeah, we want to be quick. 0, 0 cancel, right? And 480 divided by 12. Okay, 40 meter per second. 40 meter per second. Students, it's really important to transfer all your answer here. Yeah, here you have to transfer. Why? Because that's the requirement from the Cambridge. Okay, clear, students? That's the requirement from the Cambridge. Can you call other students, please? Hennessy, you are living under my unit, right? Oh, number two. Sorry, A.2. 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 Use the distance time graph to determine the speed of the train at the time 100. At the time 100 to A.2. Let's see the value here. It depends of the range. The value of 100. It is here, right? And we drag here. Okay, so it is 300 3,000 3,600. Am I correct, students?
Yes.
Yeah, 3,000 phi equals to S per T, right? Okay, so the distance is 100, correct? 100 meter, look, 100 meter over, huh? No, 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 no. 3,600, sorry, guys. Distracted. Meter over 100 seconds, correct? Gradient any part to determine the speed of the train at the time 100. Is it correct? 3,600. The speed of the, use the distance time graph. P is gradient of any part of the straight line, y over x, right? Phi is the gradient, right? 100, 3000. Okay, let's try. No, I think I missed something. Wait. Let me try first, yeah, because it's tricky. This is the gradient between this. Okay. Now this one is the gradient. Okay, so this is 85. Because the question is instantaneous, not the, what is that? Not the average velocity. And this one is 110. So the distance is 110 minus 85. And then y per x. So this is the x, yeah. Sorry. This is the x. And then the y is 3000. The y is 4200. 3006. 3000, sorry. Okay. Yeah. Okay. Okay, we get the value of y. Yeah, the gradient. Yeah, the gradient is y per x. The gradient is, we have to find the y. This is the x. Sorry, guys. Okay, so we get, nah, this is wrong, yeah. V is the gradient because at the time, this is not the average speed. Determine what is the difference? To determine the average speeds, distance over time, right? But to find the time at, to find the speed at the time, we use gradient, phi of the gradient of the graph. Yeah, gradient of the graph that passing through 100 seconds. Yeah, so we make triangle. Yeah, easy triangle here. And then we find the y and we find the x. So the gradient is phi equals to y over x. The y here we get is 102,000 divided by 25. The answer is 48. 48 meter per seconds. Now, students, if you see the mark scheme, right? The range in mark scheme from, yeah, from 50, sorry, from 50 until 60 meter per second. Yeah, we can round off 50 meter per second. Now, because you haven't learned about the instantaneous velocity or instantaneous speed, in A level later, there is a formula how to calculate it precisely. Yeah, because we are using the graph, we use the concept gradient of the graph is the the speed at a certain time. Okay? Yeah, we use y over x. But average speed, yeah, please distinguish them. Average speed is v s over t. Average speed. Average speed. Okay? Clear, students? If you make the triangle bigger, you will find, if you make the triangle bigger, let me use other color. If you use the triangle, if you use triangle, yeah, bit bigger triangle, you will find the range between 50 until 60. If you don't believe, try. Okay? But I use any triangle closer to the point. Clear, students? Clear or not, students? 2A1. Now, 2A2. Now, 2A3. Yeah. At the t, describe how the acceleration of the train at the t 100 seconds differs from acceleration t 100 seconds here differs from the acceleration at t 20. Okay, the acceleration, this is the curve, and then in here straight. Okay, let's see what is the meaning of that. Yeah, at t equals to uh yeah, at t this is a straight line and curved line. And curved line, at the curved line, curved line, the acceleration bigger than zero. Acceleration bigger than zero. Yeah, the acceleration, because curved line, the acceleration is bigger than zero. Or we can say that acceleration is taking place or greater acceleration at 100 seconds. Nah, at the time t equals to 100 seconds, yeah, the or straight line or straight line. Nah, straight line indicates that constant velocity, constant constant velocity. Nah, if constant velocity, acceleration is zero. Nah, when the time is 20 seconds, acceleration is more than zero, is greater than zero, because the velocity changes. Because the velocity, so there are 2 points to get the full mark. Because the speed changes. Yeah, the speed changes. Clear, students? Mhm. Clear or not? Thumbs up if you understand. Hey, thumbs up if you understand. Thank you. Number B. Number B. The initial acceleration of the train. A. Calculate the resultant force X on the train at this time, okay? So we can use the F equals to mass times acceleration. The mass is given above 5.6 times 10 to the power of 5. 5.6 times 10 to the power of 5 times acceleration, this is kilogram, times acceleration 0.75 meter per second square, okay? So the unit later become kilogram meter per second square, okay? Low. Okay, 5.6 times 0.75, 4.2. So the answer is 4.2 times 10 power 5. Now, 4.2 times 10 power 5. What is it? What is it, students? It is newtons. You abbreviate kilogram meter per second square into 4.2 times 10 power 5 newtons. Clear? Clear, Darren? Clear, Wening? Clear, Henny? Henny clear or not? Huh? B2. At the time 120 seconds, the trains begin to decelerate. Decelerate means slowing down or getting faster. Huh? Decelerate means slowing down or getting faster, students.
Slowing down.
Slowing down.
Slowing
Slowing
down, right? What is what is
down.
meant, what is meant by deceleration? Yeah, deceleration means the speed or velocity changes. Yeah, one mark. The speed or velocity uh decreasing or increasing?
Decreasing.
Decreases. Right? Wow, so easy. Yeah, just answer that. You will get a full mark. Correct, students. Number 3. A boat race start on the sea, but close to the land. The diagram shows the the diagram shows the boat at the start of the race. In Indonesia, we have in Lombok, the race of a boat like this. On the land of the cannon produces a loud bang. Loud bang. To start the race, there is a flash of light at the same time as the bang. One of the sailors is 500 meters from the cannon. She measures a time difference of 1.6 seconds between seeing flash of the light and hearing the bang. Because the flash will be seen first, because the speed of the light is faster than the speed of the sound, right? So here we can calculate the speed of the sound. V equals to S over T, right? S is 500 meters over time, 1.6 seconds. How much? Hey, you calculate at home, yeah? Hennessy, you have to calculate it, or if not, I will call Miss Hazel right now. I will call my friend, yeah? Nah. Okay, let's check the max. This is meter per second. Let's check the Mach scheme. Oh, should be into significant figure. So significant figure, so 3110. Okay. Correct, students? Mostly two significant figures. Yeah, tricks. In Cambridge, 2 until 3 still tolerated, yeah, in my experience. I don't know if it will change in the future. Number B, The value of the speed of the sound obtained is lower than expected. Suggests a reason for this difference. Maybe uh 1 mark ya. Nah, the sound, uh the travel of the sound, the sound travel through the air particles. When the air particles is affected by the wind, it will affect the travel of the sound. Do you understand? It means the wind disturb uh the sound to travel. So just a reason for this difference, it it's probably it's probably windy, right? It's probably windy because the sound travels through the air particle, and then the, the the wind like disturb how the sound propagates. Okay? Wait. Okay, clear, students. Number four. Oh, not enough time because I need to give extra lesson to Sec 4 also, yeah. Uh, I think we go to the short question first. Number five, yeah. Number five, yeah. Go to the short question first. Number five. You remind me, yeah, which number I skip, yeah. Number f number Oh, number three is short. Number three already, yeah. Number four. Number four is, oh, it is also short. Calculate the weight of the sign. The How many kilograms is this? Okay, this is the mass. So the weight is really easy. Weight equals to mass times gravitational acceleration. It is 3.4 times 10 to the power of 3 kilograms times 9.8 meter per second square. So the answer is, Mr. Nick, let's hang out. Oh, sorry, sir. I cannot. Wait. So the answer is 33.3 times 10 power 3, right? 33 power point 3 times to the power of 3. Okay, so the answer, yeah, 3.3 times 10 power 4, yeah, because we have to make it in standard form. This is not standard form, right? We have to make it in standard form. The unit is newtons. Okay, and then the weight of the sign acts at a horizontal distance 1.8 from the center of the support post, and it produces a turning effect about the point P. Turning effect about the point P. Okay, this point, right? It will turn like this, rotate clockwise. Um, Calculate the moment about P due to the weight of the sign. The weight of the sign, the distance here, D perpendicular is here. Yeah, here. 1.8. So moment tau equals to force times distance. Tau equals to what? Tau equals to weight, yeah. Weight times distance is 1 point. Let's see. Where is the question? To the point. Oh, sorry. The distance is P, yeah. So we need this distance. The distance perpendicular here, distance, how much? 1.8. Yeah, because this is the distance, right? Yeah, so it is 0.5. Okay, 0.5 meter, right? And then the weight from the previous calculation is 3.3 times 10 power 4 times 0.5. The unit later, Newton meter. Correct, students? So the answer is 3.3 divided by 2. Yeah, 3.3 divided by 2, 1.65. 1.65 times 10 power 4 Newton meter. So two significant figure, 1.7 times 10 to the power 4 Newton meter. Yeah. Process 1 mark. Final answer 1 mark, 3 marks. Okay. Oh, sorry.
Mister,
Yes.
Mister, how do you know if the answer should be in standard form?
I should be like that in Cambridge. Yeah.
So all our answers in MYE should be standard form.
If it is decimal, no, students. But the numbers we get in the previous one is ugly, 33.3, right? When you deal with this type of number, make it standard form. But if your calculation for the example already 302.12, like in the previous one, 302.12, you don't have to make it in standard form. Just make it into significant figures. Do you understand? But when you find the question with the standard form, because the previous one is 3.4, 3.4 is a standard form. Okay? 3.4 is standard form. Okay? if if the number includes the standard form and it's only two significant figures, so the final answer should be standard form and two significant figures. Clear, students? Okay. I need to leave, students, because I need to go to another class. See you guys. We will continue. Our test, what day, students? Answer me here.
Friday.
Friday.
Friday, Thursday, yeah. Thursday, uh, I will uh, I will finalize this annotation for this paper so we can start with the new paper. Okay, students?
Okay.
Okay, thank you.